Bless you. Okay. So originally this was when we covered proofs, and these are proofs that people needed help with, so obviously we'll come back to that someday, but not today. So we are here, okay? 6.3, tests for parallelograms. So yesterday, we knew the thing was a parallelogram, so all these properties were true. Bless you. Today, it's, hey, here's a quadrilateral, let's see if it's a parallelogram. So it's the exact same concept, but backwards, okay? So the first thing we have is definition of a parallelogram. If both pairs of opposite sides are parallel, then it's a parallelogram. It's obviously a four-sided figure. That's part of it too, right? All right, so theorem 6.9. If both pairs of opposite sides are congruent, then it's a parallelogram. Again, exactly backwards of one of our theorems from yesterday. Yesterday they said, hey, it's a parallelogram, so both pairs of opposite sides have to be congruent. Today I'm saying I have a four-sided figure. If both pairs of opposite sides are congruent, then it's a parallelogram. Do you see what I'm saying? It's the exact same thing, okay? 6.10. If both pairs of opposite angles are congruent, then it's a parallelogram. 6.11, if the diagonals of a quadrilateral bisect each other, then it's a parallelogram, exactly backwards from yesterday. And 6.12, if one pair of opposite sides are both parallel and congruent, then it's a parallelogram. So it wouldn't hurt to draw a picture next to each of these, even though I think you guys get it. Both pairs of opposite sides parallel, so what that looks like, remember the arrows? So like that means those two sides are parallel, and then I would need like two arrows on the other two sides. Does that make sense? So the top and bottom are parallel, left and right are parallel. That's enough to say that it's a parallelogram. Okay? On this one, if both pairs of opposite sides are congruent, so this to this and this to this, that's enough to say it's a parallelogram. You don't have to have like all these together. Okay? Both pairs of opposite angles are congruent. So some people still get a bit confused about opposite angles, like this one and this one. Those are opposites, right? And this one and this one. Okay? These two are what? What's their name? Not opposite. Consecutive. Adjacent technically is sort of right. Consecutive, okay? So consecutive means not opposite. It means like if I'm going clockwise or counterclockwise, it's the very next angle, right? If the diagonals of a quadrilateral bisect each other, so diagonal, diagonal, congruent, 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 congruent. I know it's kind of small, but do you guys get it? Okay. And then the last one, it's a little easier to see now. If one pair of opposite sides are both parallel and congruent, so they're parallel and congruent, just one pair. I don't need both pairs if I do it like this, right? They could have had the other two sides instead, but just one pair had to be both parallel and congruent. Okay? Do you guys get this is literally just yesterday but backwards? Same thing, all right? So when you're ready, it says determine whether each quadrilateral is a parallelogram and then why. So the explanation to me is the theorem. Typically, I wouldn't want you to write like theorem 6-12. I don't want you to memorize those or anything, but for the sake of not having to write a whole sentence, you can do that today. That's fine. Okay, but like on a test or a quiz, I'd want you to say both pairs of opposite sides were parallel or something. All right? All right, number 9. Is this a parallelogram? Yes or no?
Yes.
Yes. Which theorem led you to believe that? 6.9. Which says, which one is that? If both pairs of opposite sides are congruent, then it's a parallelogram. So again, on a test, I don't want you to memorize that that's 6.9. That's not helpful, right? You would tell me the words instead. But for the sake of time, you can just write theorem 6.9 because it's right above you. Does that make sense? Okay. Number 11, I suppose, would be next. Yes or no? No. Right? All I know is that these two are congruent. That's it. I don't technically know anything else, right? So I'm going to say no, and then I said we don't know about the top and the bottom. That's probably enough. Don't know about top and bottom. You could have said that differently, but that makes sense to me. Is that okay? What about letter X? Yes or no? Yes. Which theorem? Theorem 6.12, which says if one pair of opposite sides are both parallel and congruent, then it's a parallelogram, which that's what we have.
At the top it says if both pairs of opposite sides are parallel.
Yes. We don't know these are parallel. There were no parallel signs, and we're not supposed to technically assume that, even though they look parallel, right? Oh.
So, like, could you just, is that like a theorem at the top? Like, do you have to know that the sixes are there?
So, this is telling me that, right? So this is that theorem 612. I don't know that these two are parallel, even though they look like it.
Could those two have little arrows?
These two?
Yeah.
They could. Yeah, if they did, it would probably be a different theorem, though. Right? So if they had given me, I think this is what you're saying. You're saying if they had done this and this?
Yes.
Okay. So if that's it, then that's just the definition where both pairs of opposite sides are parallel. That wouldn't necessarily be a theorem. That would be the definition of a parallelogram itself. So you could say that too. You could say definition of parallelogram. Okay? Anybody confused? Pretty easy, right? Okay? Find x and y so that the quadrilateral is a parallelogram. So they're telling us it's a quad. We know that. It's 4 sides, right? But they're saying make it work so that it is a parallelogram. So if this were a parallelogram, what do I know about these two opposite sides? They're congruent, right? So I already know that I can say 4x minus 17 is equal to 2x minus 1, right? What do I know about these two alternate interior technically angles? They're also congruent because these two sides are parallel, right? Cut by a transversal, so alternate interior angles are congruent. So I also know that 3y plus 5 is equal to 5y, what's that, minus, is that 13? I wrote over it. Okay. So we're going to solve for x here, right? We're going to subtract 2x on both sides and get 2x, and we're going to add 17 and get 16. Divide by the 2, x is 8, right? You guys try the y, if you haven't already. Okay. Subtract the 3y, you get 2y. Add the 13, we get, what's 5 plus 13? 18. Divide by the 2, 9. They said find x and y. We did. Have I lost anybody before we do this last one? It's pretty easy, right? Okay. On this last one, graph the quadrilateral, then determine if the quadrilateral is a parallelogram by each method. So you guys already graphed it while we were waiting, right? So I'm going to graph it too. You want to check it, make sure it looks right, okay? What they want us to do is different ways of proving this. Thanks, just said now. It's perfect, thanks. So I'm going to go ahead and graph it, and then I'll tell you the plan. So J is at -4, so obviously left 4, down 4. 1, 2, 3, 4. Make sure you're labeling them. J, -3, 1, 1, 2, 3, 1. K, L is 4, 3, 4, 1, 2, 3, and 1, 2, 3. Is this right? I'm going cross-eyed on this. Is that right? Looks right to me. Okay. Connect them the best you can. Now, I did not use a ruler, so I'm not going to trust my drawing very well, right? I'm not going to be like, well, those look parallel. I don't really know. I didn't use a ruler, okay? So what we're going to do is the first one we're going to do is prove it by the distance formula. If I'm trying to prove whether this is or is not a parallelogram by the distance formula, which of the theorems from above would be helpful in that? 6, 9, if both pairs of opposite sides are congruent, then parallel, that would be helpful, right? So if I find, I'm going to start with just 2 pairs, right? I don't want to find all 4, because like if the 2 opposites, for example, if like KL and JM are not congruent, then I can just quit, right? But if KL and JM are congruent, then I've got to check the other 2. I've got to check the KJ and the LM. Does that make sense? Okay? So what do you guys want to check first? It doesn't matter. KL and JM? Okay, so let's find KL, okay? If you use the distance formula, here it is. Distance equals square root x2 minus x1 squared plus y2 minus y1 squared. If you do Pythagorean theorem trick, right? If we're doing KL, this is our right triangle, right? So this is 2, it looks like, and 1, 2, 3, 1, 2, 3, 4, so 7. Right? So I would do 2 squared plus 7 squared, right? So what is 2 squared? 4 and 49, right? Which is, so square root of 53 is what KL is. Is everybody okay with that? All right. So now I'm going to find JM. Those of you that did it distance formula way, if you don't get square root of 53, will you please let me know so I can do it for you and make sure it's okay? All right, so let me know in just a second. JM, we're going to draw our right triangle, right? It looks like, if I'm counting right, I think that's a 1, right? And 1, 2, 3, 4, 5, 6, 7 again? Is that what you guys are getting if you're doing it that way? Is that 1 and the 7? So 1 squared and 7 squared. Obviously 1 squared is 1, 7 squared is 49, so I get square root of 50. Is square root of 50 and square root of 53 the same? No. So we could technically stop, right? Did anybody do distance formula and not get those? And you need me to show you? Okay. It said determine if it's parallelogram. So because those two sides were not congruent, I could stop. Technically, you could find the other two, but I don't really see a point in that. If these two are not congruent, I would say no, right? Not congruent because, what did we have? KL was not congruent to JM. Something like that, right? The next method you guys have is the slope method, right? The back of your notes is blank, I think, right? So if you need some space, you could go on the back. So if we do the slope formula, we already know that this is not a parallelogram, okay? But I'm showing you all the different possible ways of proving it because the question might ask you slope when I didn't. So if we were doing slope, how would we do that? Which theorem would we use? Or definition? If it's just slope alone, it would be the definition, right? So I would see if KL was parallel to JM, and if that was yes, I'd keep going, and I'd see if KJ was parallel to LM, right? So we can do slope by counting rise over run. That would take us like 2 seconds, right? So if I do the slope of KL, if I rise, it looks like we rose 2 and we ran 7, right? Positive, positive. And then the slope of JM, if I rise 1 and run 7, I would say not a parallelogram because KL, slope of KL, was not equal to slope of JM. If they were, I would have checked the other two, right? And they'd have to be parallel as well. And then we're not going to do the third one. We're just going to talk about what we would do. The distance and the slope, which theorem would be helpful with that one? The 612, right? The one that says one pair of opposite sides are both parallel and congruent. So I would have to prove that like KL and JM were parallel. Well, we already said they weren't, so I would have stopped there. But I also would have had to say that KL and JM, just those two, were congruent. And again, it was still no. Does that make sense? Okay? Bless you. So no matter what, the answer here is no, no matter how you solve it. On the questions, they don't typically ask you to do like 3 different ways. They ask you one. I just wanted to show you all the like options. Probably, I don't know, I'll check in a second. Okay? Do you guys have any questions anywhere? Just curious, does anybody use distance formula anymore? No? Nobody? Oh, okay.